Hello, in this video we are going to cover section 4.2 from your textbook, which is called Measures of Central Tendency, which sounds kind of complicated, but I think whenever you see what we're going to talk about, you'll recognize it, and it's pretty easy. So let's talk about what measures of central tendency are. So rather than listing every single number or every single data point in a large distribution of numbers, people tend to summarize that data by selecting some representative number and calling it the average. Three figures, the mean, the median, and the mode, describe the average or the center of a distribution of numbers. And it's just going to depend on your distribution, which one of those figures you want to use. If you want to use the mean to describe the center, if you want to use the median, or if you want to use the mode. And these three averages are known collectively as measures of central tendency because they describe the center of the distribution of numbers, or the center of the data set. Alright, so we're going to go through each one individually. First one we're going to talk about is the mean. The mean is the average that most people are familiar with, and this is most of the time what people are going to use to describe the center of their data set. But there are situations where you'll see people use the median or the mode. So it says, given a collection of n data points, so it's labeling the data points here, x1, x2, all the way to xn. So each of these little x's represents one of your data points. So if you have a collection of data points, the mean is found by adding up the data and then dividing by the number of data points. So over here on the left, you see the formula. The mean of n data points is found by adding up all of the numbers and dividing by n, where n is the number of data points that you have. Now let's talk about some symbols that you'll need to be able to recognize. The first bullet point here is the most important symbol, and then the second bullet point at the bottom, that is just for you to know for whenever you go into your statistics class. That's what class most people will go into after this class. It says if the data are collected from a sample, then the mean is denoted by x bar. So it's x with a little line over it. And in this class, unless we state otherwise, we will always assume that the data represent a sample. A sample is a subset of a population. All right, so for example, let's say that I wanted to do a survey about all of the students at CCGA. The population would be every person that is enrolled in a class at the College of Coastal Georgia. My sample would be the students that I select to be in my study. So rather than giving a survey to all, 6,000 students at CCGA, it's going to be easier for me to pick something maybe like 100 or 50 students and survey them. Those people that I pick to be in my survey, that's my sample. The population is the big group. All right, so population is big, sample is smaller. It says at the bottom, like I said, this is just for you to know for when you go into your statistics class. It says if the data are collected from an entire population, this is sometimes called a census, then the mean is denoted by this little Greek letter. It's a lowercase mu, so it kind of looks like an M and a U. All right, so easy to remember, mu. Looks like an M and a U. All right, but we are going to always use this first symbol up here that you see, X bar, to denote the mean in this class. Now, I need to briefly talk about sum notation. We're going to see it again in the next section, so it's important that you understand what this Greek letter means whenever you see it. Mathematicians have developed a type of shorthand called sum notation to represent the sum of a collection of numbers. If you see this Greek letter sigma, this is a capital sigma, right here, let me circle it, right there, capital sigma. Capital sigma corresponds to the letter S in our alphabet, and it represents the word sum. So anytime you see that symbol, you want to think sum. Given a group of data points, x1, x2, all the way to xn, we can use the symbol, the sum of x, to represent their sum. Right, so hopefully you just saw how I read that. Let's see if I can underline it here. Right, so right here, that is read as the sum of x. So we're using the symbol sigma x, or the sum of x, to represent their sum. So that is, if you see sigma x, that means add up all of your data points, x1 plus x2 plus all the way to xn. Let's look at our first example. It says find the mean of the following data set. So we have 16 numbers here if you count them up. 2, 4, let me make sure, 2, 4, 6, 8, 10, 12, 14, 16. Yes, 16 numbers. All right, so to find the mean, you're going to add together all of the numbers and then divide by 16. So why am I dividing by 16? I'm dividing by 16 because that is the number of data points that I have in my data set. All right, so you count up how many numbers there are in your data set, and that's what you divide by to find the mean. All right, so to find the mean, remember the mean is represented by the symbol x bar with x with a little line over it. So we're going to add together all of those numbers and then divide by 16. All right, so go ahead, pause the video, and we'll see if we get the same thing. All right, so I actually had to come back and re-record this because I added them wrong the first time. I was trying to use Siri to add all of them up, and she cuts off after like 12 numbers. Okay, so when I added them up again, I got 424 for the sum. So I'm taking my sum and dividing it by 16. So 424 divided by 16 is 26.5. Let me tell you how I knew that my answer was wrong the first time. The first time I recorded this, I said that the answer was like 17.8. But when I looked at the numbers in the data set, there are no ages younger than 18. So I knew that the average couldn't be 17. All right, so make sure that your average is a number that falls in between the lowest data point and the highest data point. That's a good way to check your answer. Because it's really easy whenever you're going through this to skip a number, or even to skip a couple of numbers as you're going through and adding up all the numbers in your data set, especially when you have several numbers like we do here. Now let's talk about the median. The median is probably my favorite one to find. I think it's the easiest one to find, or one of the easiest. They're all pretty easy. But the median, just like how the median is the middle of the road when you're on the highway, the median is the middle value in a distribution of numbers. Then the median separates the distribution into two equal parts, and so as a result, it can be viewed as a form of an average. All right, so to find the median, your first step is to put the data in numerical order. This is the most important step, and this is the step that people always forget to do when they get to the test. All right, so make sure that you put the data in numerical order. And what I mean by that is put them in order from smallest to biggest. All right, so it also notes here, if a number appears more than once, we're going to include it as many times as it occurs. All right, so if you have 2 2s in your data set, make sure you put 2 twice. If there's an odd number of data points, the median is just the middle data point. If you have an even number of data points, like we just did with our last data set, the median is defined to be the average or the mean of the two middle values. Okay, so if you have an odd number, it's just going to be the middle data point. If there's an even number of data points, the median is defined to be the mean of the two middle values. So let's look at a couple of examples. All right, here's our example for the median. It says find the median of the following sets of raw data. I think what they mean by raw data here is that the data are not in order from smallest to biggest. So don't forget, that's always your first step. All right, so part A, Here's our data set: 2, 8, 3, 12, 6, 2, and 11. Another sort of hint or maybe advice that I would give you about finding the median is make sure you draw like a little bit of space in between each one of your numbers, because if you come back and look at it later, you know, like 2 and then 8 may look like 28 if you write them too close together. Okay, so the first data set, if I put it in order, that goes 2, 2, 3, 6, 8, 11, 12. Alright, so 2, 2, 3, 6, 8, 11, 12. Now to find the median, this is how I like to find the median. I just go through and I cross one off from each end until I get to the middle. So I've crossed one off from each end. Now I go again, cross one off from each end, and then cross one off from each end. And there's our median. So the median here is 6. We don't have a fancy symbol for the median. Some books will use a capital M, but our book doesn't use a symbol at all. Alright, and then our next data set, it's actually the exact same data set, and then there's just an additional 8 on the end. So if we put it in order, that goes 2, 2, 3, 6, 8, 8, 11, 12. Alright, so let's again start crossing off from each end. Cross off from each end. Now do it again, all the way until you get to the middle. Alright, and now here you see we've ended up with 2 values in the middle. So, just like we just said, super easy, don't panic. All you have to do is just find the average of the middle 2 numbers. Alright, so the average, or the mean, I should say, is where you just take the numbers, add them up, and then divide by the number of data points. So you're going to do 6 plus 8 divided by 2. 6 plus 8 is 14, so 14 divided by 2 is 7. And there's your median. The median here is 7. And our third and last measure of central tendency is the mode. The mode is the most frequent number in a collection of data, so it's the data point with the highest frequency. And it says, because it represents the most common number, the mode can be viewed as a form of an average or a form of the center of the data set. And it says at the bottom, a distribution can have one mode, it can have more than one mode, it can have 3 modes, it can have, multiple modes, and it can also have no mode. So a no mode is going to occur when each number appears the same number of times. So each data point occurs the same number of times. So nothing occurs the most frequently. Here's an example. We have 3 data sets, and we're going to find the mode of each of the following data sets. The data sets do not need to be in order from smallest to biggest when you're finding the mode. The only one that they need to be in order for is the median. Alright, so let's look at the first data set. 4, 10, 1, 8, 5, 10, 5, 10. Alright, so there are 3 10s, so the mode is 10. So it's the number that appears most often. Alright, and it says, this data set is called unimodal because it has only one mode. Alright, notice our second data set. It says 4, 9, 1, 10, 1, 10, 4, 9. Notice that each number appears twice. So since each number appears twice, there is no number that occurs the most frequently, and so we say there is no mode. In our last data set, part C, it's 9, 6, 1, 8, 3, 10, 3, 9. Alright, so I see two 9s and 2 3s. Alright, so those are the ones that appear the most often. So we have 2 modes here, 9 and 3. You can see here I've separated them with a comma. I'm pretty sure that's how they want you to do it on the homework. Make sure you read the directions carefully, so you'll know how to write it. And it says this data set is called bimodal because it has 2 modes. If they have 3 or more modes, they usually just call that multimodal. All right, I wanted to go through this problem from the homework because I think it's a little bit different than what we've done in the notes so far. I'm sure a lot of you could probably figure this out on your own, and maybe you've done this before for one of your classes. But just in case you haven't done this before, I wanted to show you how to do it. It says Katrina must take 5 exams in a math class. If her scores on the first 4 exams are 71, 69, 85, and 83, what score does she need to make on the 5th exam for her overall mean to be the following? A, at least 70, B, at least 80, and C, at least 90. I'm going to show you how to do part A, and then from there I know you'll be able to figure out how to do part B and part C. Now, another reason that I chose this problem for the homework, even though it is a little bit different than what we've done in the notes, is because I think this is a useful skill to have. If you are a nursing major, which I know a lot of you are, a lot of times they want you to have a certain test average. So they may want you to have a 75 test average. And so if you have, let's say you're like this person, you have 5 exams, and you know the scores that you got on your first 4 exams, you can figure out what you need to make on that last exam to meet that 75 average. And I'm sure that a lot of you could probably figure out how to do this just by plugging in random numbers, but this is going to save you some time, and it's not complicated. This uses stuff that you've already done before and that you know how to do. Alright, so this question deals with the mean, so let's proceed as if we were going to find the mean. Alright, so the mean is equal to, we're going to take the sum of her first 4 exams, so 71 plus 69 plus 85 plus 83 plus x. X here represents the score on her 5th exam, which we don't know what it is. She hasn't taken it yet. And we're going to divide all those numbers, or that sum, by 5, because there are 5 tests. Now the difference here, why this is different from just finding a mean like normal, is that we already know what the mean should be. They told us that the mean should be at least 70. Alright, so we're going to plug in 70 for the mean. Alright, so the word mean got replaced with 70. Now, let's solve for x. X is going to be what she needs to make on the 5th exam for her overall mean to be or her test average to be at least 70. Okay, so we're going to start by multiplying both sides by 5. This is going to get rid of the fraction on the right-hand side. I know all of you hate fractions, and so we're going to get rid of this one before it can get any worse. Alright, so multiply both sides by 5. I'm multiplying by 5 because that's what's in the denominator. Alright, so I'm multiplying by 5 on the right-hand side, multiplying by 5 on the left-hand side. Whatever you do to one side, you got to do to the other side. This is going to cancel out the 5s. One of the 5s is in the denominator, and one of the 5s is in the numerator, because you could imagine this is like 5 over 1. So they cancel each other out. Now on the left-hand side, 5 times 70 is 350. So we have 350 equals, and then just our previous numerator, 71 plus 69 plus 85 plus 83 plus x. Now this is really simple from here. This is a very simple linear equation. I know you can solve for x. So you're going to add together the like terms on the right hand side. So that's the 71 plus 69 plus 85 plus 83. If you add those together, those sum to 308. So we have 350 equals 308 plus x. And I'm sure you know what to do next. Next, you just need to subtract 308 from both sides to get x by itself. Alright, so if you subtract 308, that leaves you with x equals 42. So Katrina only needs to make a 42 on her last exam for her overall test average to be a 70. Alright, so let's think about what are you going to do differently when you go to do parts B and C. So the only thing that you'll have to do differently is what this number will be right here. So instead of a 70, if you were doing part B, that would be 80. If you were doing part C, that would be 90. Alright, so I know you guys can do that, those two by yourself. Now, once again, if you have any questions, please email me, or you can post in the coffee shop Q&A section on our discussion board.